Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Beginning R Part 3. Now this part is at chriswoods.com/beginningr, and we've now moved on to the page which is lists. Now until now, all of the variables we've used have contained a single piece of information. For example, A is assigned from 4, means we've assigned the piece of data 4 to the variable A. Now it's very common in programming and in fact in real life that we want to refer to collections of data. So for example, a shopping list will contain a list of items you want to buy, and a car park will contain a set of cars that are in the car park. Now we're going to now create a list. A list is a way that you can combine lots of bits of data into one variable. Now to start, we're going to first get rid of our hello.r because we're going to move on to list.r. So we're going to do file, create a new R script, and we're going to call this list.r. So I'm going to click save, and then save this as list.r. Not in tags. List.r. Excellent. Now to create a list, we're going to use the function c. So I'm going to call my list, and I'm going to assign the data c, and then cat dog 261, and then I will print my list. I can now run this by typing R script, and now remember we've changed the script now to list.r, so I'll type list.r here, and you can see it's printed cat dog 261 to the screen. Now this has created an R list, which in some languages is also called a vector, which has 3 bits of data inside it: cat, dog, and 261. And this list has been assigned to a variable which we have called myList. Now I could have called this thing anything. I could have called this shopping. Then I could have printed it here as a variable name shopping. So the name of the list does not make any difference. It's completely arbitrary. But generally you should choose a name which is meaningful so that people can understand what it is you're creating. So in this case, this is just a list, so we'll call it myList. Now you can have as many items in the list as you wish. So I could place more things in here. I could have horse, fish, etc. We can now see that this list has 1, 2, 3, 4, 5 elements in it. And equally, I can have nothing in the list. So if I put nothing between C, then here we have a nothing list. It contains nothing. A null is nothing. Now this list can contain many different types of things. So you saw before I mixed strings and numbers. I can just have numbers on their own if I wanted. So in this case 62, 32, 65, 3, 867, 3 minus 5. This is just going to be a list of numbers. Right, so this now brings us down. I've walked you through this material. First exercise of this particular part, could you now create a list.r yourself and then edit it so that you can have some different items in it. Try adding in strings and integers and floating point numbers and even rearrange the items. Make sure you save the file and you rerun it in the terminal and check the output matches what you expected. And as always, press pause now so you can have a go at this and then unpause when you're ready for me to show you the answer. Okay, I assume you've now unpaused, you've had a go at this. I'm now going to walk you through the answer. So let's add some more items to this list. So what I'm going to do here is I'm now going to have cat, dog, and there was 261 as we had before, but I'm going to add some things on the end. So hello, and let's put a floating point number in there, 5.76. And if we now run this, there we can see we've got these 5 items in the list. Now we can edit it, we can put these in different orders. So let's put 261 first, so we're not going to have it here. Remembering a comma between all of these parts. And let's move the 5.76 and move that before dog. And now if I print it, you can see that the items are printed in the same order they've been put into the list. That's because the items in the list are in the same order that you've placed them. Okay, so that's the answer. I hope you had a good play with that. So the power of R's lists comes not simply because we can put lots of pieces of data into the list, but also because we can then get that data out and we can choose specific items of data. Now the primary method of getting data out is called indexing. Now indexing a list in R is done using square brackets. So let's say here I want the first item out of the list. this 261, I can get that item out by using square brackets. I'm going to call this variable my element, and that'll be by using the variable name for the list, my list, then square bracket, and then the number corresponding to the order of the item in the list. So the first item, 261, is at index 1, and so my list 1 will be 261, and if I now print this, so I print my element, you will see 261 printed to the screen. Equally here, if I wanted to print dog, well, dog is 1, 2, 3, 4, so it's the fourth element, so I'm going to use the index 4, and then when I run this, I get dog. Now, those of you that have come from a programming language like maybe C++ or Python might be slightly surprised here, because in R, we count from 1. So the first item in the list is 1, second is 2, the third is 3, fourth is 4, and the fifth is 5. But in other languages, so sort of Python and C++, etc., they count from 0. And so for them, the first element is 0, the next is 1, 2, 3, 4, etc. Now this doesn't really cause you as an R programmer any issues, but if you're moving backwards and forwards between R and Python, just remember that R is what we call one indexed, so we start from 1, whereas Python, C++ are 0 indexed, they start from 0. And also you may notice here I've started these lines with these little hash symbols. That means a comment. So a comment is a line that the R will not read, it's just for humans so that we can read it. And you notice if I run the script, it hasn't changed it. The comments are always ignored. So that brings us now on to the next exercise. So what I want you to do is basically edit your list.r and have a go at accessing some different elements from the list and putting in different numbers between the square brackets. As ever, press pause now, and when you come back, I'll show you the answer. Okay, you've unpaused. I assume now you're ready for me to show you the answer. So I'm going to go back to my list, and I'm going to create a list here which just contains 3 elements, which is going to be cat, dog, and 261. To get the first element out, we can get that by looking at my list, square bracket, because that means index, and we want the first element, so that's going to be index 1. And then I can print my element, so that should print cat. Now if I want another element out of here, and I'm going to call this my other element, and I could have called this any variable name that I wanted, I can maybe perhaps get the third element out, and that'll be my list, square bracket 3, to mean give me the third element. Then I can then print that, my other element. There we are. If I now run this script, what do you think will be printed to the screen? It should be the first element, cat, my list 1, and then the third element, 261, which is my list 3. And there we have cat and 261 printed to the screen. Now, indexing, if you played with this, you may have tried something, and well done if you did try this. What would happen if I look for the fourth element in the list? So there's only 3 elements here, so let's see what happens if I go and try for the fourth element. And as ever with programming, do try these things out. You learn programming by exploring. So if I try and get the fourth element, it doesn't exist, so let's see what it prints. It prints this, NA. NA is short for not available, and an NA will pop up a lot in R, you'll come across them quite a bit. It's returned whenever something is not available. Now, you can test if something is not available by using the function which is is.na. So if I print is.na, my element, that is asking, is my element an NA? And in this case, if I run this script, we can see it prints true. True means, yes, this is definitely an NA element. Whereas if I do this for my list 1, which will be cat, we printed cat, and cat is not NA, so it gives you false. Now do be very careful in R that you do check for values that are NA, and a common source of bugs is basically continuing to work with elements in a list that don't exist. You've accidentally asked for something that isn't there. Now this will then bring you to the question of, well, how do I know how many elements are in my list? You can do that using the function length. So if I type length and then the list, that will calculate the number of items in the list. And so here, it's 3. Indeed, I can assign that, so I can say list length equals length mylist, and then if I print that, we will get the same answer. So again, you may want to check that you are actually accessing a valid index, and a valid index will be 1 to the number of items in the list, or the index must be greater than equal to 1 and less than equal to the length of the list. Now, so far we've put items into the list, but let's say we want to change the items that are already there. So we can do that by using assignment into the list. So here we have cat, dog and 261, but let's say I want to change this first item, cat, which is my list 1, and I want to change that into fish. Well, that's exactly how I do it. I'm saying assign the data fish to the first item in the list, so it will replace cat. Now if I print my list, we can now see we've printed fish, dog and 261. Now note that you can update any item in this list, including items that don't exist. So if I say my list 8 equals fish, what this will do now is it will set the 8th item to fish. The first, second and third items were already there, but because there was nothing in items 4, 5, 6 and 7, R has automatically added those items and set them to the value of NA because there was nothing there. If we look at the length of this list, length of my list, we can see it's automatically increased the size as well. And indeed we can print that beforehand to show that before we added the 8th item, the list had a length of 3, then fish was added at item index 8, the list was extended to be size 8, 4, 5, 6 and 7 indexes were added as NAs as not available, fish was added as the last item, and the length of the list afterwards is now 8. Now, as well as being able to select individual items from a list, you can also select subsections of it in one go. Now, the process of asking for subsections is called slicing. Slicing starts out the same way as indexing, so we are going to be using a square bracket. So let me now create a list which is going to be slightly bigger. So 3, 5, green, 5.3, house, 101. Okay. Now to create a slice, and I'm just going to call this my slice just so we know what it is, but you could use any variable name you want. We start off by using the name of the list, and then in the square brackets, instead of just writing one index, we use C to pass in a list of indexes. So if we do 3, 4 and 5, this will ask for the items at index 3, 4 and 5. Well, that's going to be green, 5.3 and house. And so if I now run this, you can see green, 5.3 and house are now indeed returned. Now writing out C, 3, 4, 5, it's kind of okay when we only have a small number of things to type, but if I wanted 100 items for the list, my hands would fall off by typing 3, 4, 5, 6, 7, etc. And so to make this easier, there is a function called seek, which is short for sequence, and seek will basically generate those numbers in order from the first number to the last number. So seek 3, 5 would be 3, 4, 5, and you can see it picks it out there. Indeed, I can show that to you even more by just printing a seek, and here let's print 1 to 100. And there you are, you can see seek is generated there 1 to 100, and here we've used seek to give 3 to 5, so we've sliced out green, 5.3 and house from this list. Now you can generate sequences in steps. So for example here, if I did 1 to 100 and then 2, what this does is it has generated the numbers between 1 and 100 with steps of 2. And if I wanted to do a countdown, I could do a reverse, so I could start at 10, I could go to 1 in steps of -1. If I now run this, you can see it's given us a countdown 10, 9, 8, 7, 6, 5, 3, 2, 1. And that means if I wanted to reverse my list, I can see there's 1, 2, 3, 4, 5, 6, 7 items in here. If I did 7 to 1 in steps of -1, just get rid of this line, you can now see that has sliced the list in reverse. We've just completely wrapped it around. So I've just walked you now all the way through this section, just to show you where we are in the notes. And now we're going to look at negative indices and masking. Now, you can use negative indexes to mask out elements from your list. So let's imagine I'm going to start here with a list which is going to contain red, green and blue. So let's type that in. Red, green and blue. Now if I print my list -1, what that means is mask out the first item, so remove it effectively. And so we'll only print green and blue. If I want to mask out the second item, then I would use -2. And if I want to mask out the third item, I would use -3. So you can see we've masked out the first item, second item, and then the third item. This is because my list -1 means give me everything except for the element at index 1. Similarly, my list -3 means give me everything except for the element at index 3. Now similarly, just as we used C to pass in multiple indexes, we can mask multiple indexes at the same time. So if we wanted to have everything except -1 and -2, we could put this in with C here, and obviously if we wipe out -1 and -2, that will mean we will only have blue left, and so blue is printed to the screen. Now you can also mask by passing in a list of booleans. So booleans are what we call true and false values. So here we have 3 items. If I pass in here false, true, false, that would mean don't give me red, do give me green, don't give me blue. So if I run this, this will then print green. If I wanted red and blue, then I would change this to true to mean do give me red, don't give me green, and then let's say do give me blue. And there we've got red and blue. So true, all in capitals, means yes, do this. False, all in capitals, is then no, don't do this. So that's brought you through masking, and hey, we're at another exercise. So what I'd like you to do now is I'd like you to edit your list.r to print various different slices. So just have a play. Make sure you understand why you get an NA if you do get an NA. And again, press pause now so that you have a chance to have a go before I show you the answer. Okay, you've unpaused, so I assume it's now ready and time for me to show the answer. Let's have a go, let's have a play with this. And again, I learned programming by basically playing with things and trying to break them, and I encourage you to do the same thing. So we're going to do 3, 5, green, so this is our initial list, 5.3, house, 101, there we are. First thing I'm going to try and do is print my list, and we're going to take a sequence which will just be items 2 and 4 from the list. What does that do? And I've got a slight typo there. Aha, there we are. Notice that little red thing popped up, and that showed me I'd made a mistake in my typing. There we are. So we've basically just picked out 2 to 4. So 1, 2, 3 and 4, we have the items. Let's do the same thing with items 3 to 5. Yep, green 5.3 and house. Let's now just have a single item. So what happens if I put in seek and then 1 and 1? What's that going to do? Yep, just the first item in there. So seek 1 and 1 would just be item number 1. Okay, let's try putting in sequence, and now we want items 1 to 7 in steps of 2. So what's that going to be? 3 green house 1, 3 green house 1. That was 1 to 7 in steps of 2. And let's reverse it. Remember how I showed you how to reverse it a bit earlier? Well, we're going to do 7, 1, -1, and that will reverse. And how about we make this a little bit more general? We can say length my list, so we don't have to remember that it's 7. And there we are, that's done that as well. Okay, So that's the answer to that section, to that exercise. Let's move on. So we're now going to move on now to adding things to lists. So in addition to updating the list, you can also add items to the end of the list, and we can do that using the append function. So let's imagine now I'm going to create a list that just contains cat and dog. Now I can append to the list using the append function, and this takes the name of the list as the first argument, and then the thing we want to append as the second argument. And then it returns the new list, and this is why we have to assign it back to my list here. If we now print this, you can now see we have cat, dog, horse. Horse has been appended to my list, which was cat and dog. That resulted in a new list called cat, dog, horse, which we've assigned back to the variable my list. We could equally create another list. So for example, here I'm going to create another list if I can type. Here we are. See, I'm going to put a fish in here and a zebra. There we are. And we can actually append to my list the contents of the other list. So what you can see here now is we've now put fish and zebra onto the end of cat, dog, horse. Now the combine function does a very similar job to append, so you can sometimes see it being used to append items as well. So for example, if I go here and I've got my list is cat and dog, some people will actually just type C my list horse, and that's a slightly easier and quicker way of doing it. Equally, if I then create my other list is my fish and zebra. There we are. I can say my list is C, my list, and then other list. So again, you see C being used sometimes as a shorthand effectively for append. They're kind of doing a very similar job in this particular case. Now, in my opinion, your code should be descriptive and should describe the intent of what you actually want to do. So while C is quicker, I do generally recommend append, just because to somebody who's having a look at this code, sorry, that's a C because it's creating a new list, just for someone looking at the code, having append just lets them know as a quick look exactly what's going on. Okay, so that's now brought us to the end of the lists. So we've now finished part 3. So the next video will take you through part 4, and I look forward to seeing you there.